going to try and talk about some of these things. So I decided to kind of title my talk, If You Build It, Who Will Come? So of course, this is in reference to, okay, we're going manual, or something. That's a fun. Oh, okay, here we are, we're going. Okay, great. So it's of course in reference to the 1989 movie Field of Dreams, in which the protagonist, played by Kevin Costner, has a voice tell him, if you build it, they will come. And so I'm going to spoil a 34-year-old movie by telling you that it is a baseball field. He builds it, and they actually come. So this is the kind of thing in people's minds doing an open source hardware project is, okay, I'm going to go through all this effort. Is anyone going to care? Is anyone actually going to do it, right? So if I build this, will anyone come? How many people will come? You know? And so what I'm trying to encourage you today in this talk is to think about the who's going to come, and then to try to tailor your project around that. So imagine you're in the position of a user, and you're trying to think of what's the ideal open source hardware project. Well, in that case, people are not only different, but also even a single person has different modes of what they're interested in. So for a point today, I'm going to have kind of two extremes. Maybe one person who's already has a project, it's already underway, and there's like a very specific component they need. So they call that person the focus project. Another person might be more of a person who just likes stuff and is a curious hobbyist, right? And so, for example, how might they come across your project? Well, if you're focused, you had an intentional web search trying to find a component. I need something that does X, right? Versus maybe you're a hobbyist, you saw something cool on social media, maybe you saw a great talk here at Latch-Up, and like, oh, that sounds like fun, I want to go play with that, right? And so different ways of kind of approaching it. And so this kind of difference of how you approach this and kind of keep going, right? For example, when you think about what's the most important thing about it, you care that it works, right? I need this functionality, that's the most important thing to me. If you're more kind of playing around, maybe you just care it's interesting. This is kind of fun. This is like a cool thing to do. And same thing kind of continues, right? Language, you care it's compatible with whatever you're doing versus, actually a new language is a feature, right? I want to learn something new. I want to kind of try something out, right? And so obviously there's many more dimensions to this. I just want to kind of get people in the mindset of thinking about how when you approach a project, you may have certain goals or mindsets in mind and certain objectives, right? So kind of the whole point of today's talk, right, is I'm going to, given you all make open source hardware, awesome. So I want you to think about what the community supporting needs and to try to tailor what you're doing to better support that. And so there's a lot of technical issues. Today is actually more about the less technical issues that are still extremely important, right? So thinking about things like support, automation, documentation, and perhaps when you realize you misunderstood your community, taking a big pivot, these are all things to kind of consider. As kind of a bonus problem, I'll also talk a little bit about how do you prioritize when you have limited resources. Okay, so going back to that first slide, thinking about these two different extremes of users and how those good things I mentioned might help, well, they're all helpful, right? So it's all green pluses here. But you can imagine maybe under certain circumstances, you might have different priorities, right? For example, for the focus project person, you really care that it does the thing it does, and automation can help you get there, right? Okay, out of the box, default thing with a simple make command does what I want. Perfect, great, I'm done. That's the most important thing. I don't want 100 pages of docs because it did what I needed to do. Versus if you're curious to go play around under the hood and write code with it, then you care more about documentation. So you can kind of see how already, depending on who you're serving, you might have different priorities or goals. So to help kind of maybe explain how I'm going through this, I'm going to do a quick explain where I'm coming from. So like my two colleagues over here, I'm a assistant professor at UC Santa Cruz. Do a number of research projects. I have the good fortune to work with great students. And so in our group, we're doing a few things. Number one is RTL simulation. So that's the project we'll hear about later today, or actually later in this talk, I should say. We also have performance graph processing, and we're writing cryptography accelerators and chisel. So we're kind of doing a variety of things. Before I was there, I was at LBNL as a postdoc. And before that, I was part of this Berkeley Army and working on not only graphs, but an early user and contributor to RISC-V and chisel stuff. So I've attempted with John's prompt to put together a talk today to talk about some of the projects I've done and put some overarching narrative about what are some of these aspects about open source to kind of make these projects helpful or more successful. So as I said, support, usually a good thing. Sometimes people might see it as tedious, but let's kind of think about it, right? So when I say support, it's any way you kind of help users use your project, right? It could be email, some sort of mailing list, forum, etc. But clearly it's helpful, right? I think the thing that maybe is not appreciated enough is that by doing support, you actually interact with your community and you can learn more about them, like whether there are sticking points, how they're using your product or your resource, right? And so that's kind of the key thing, is learning more about their needs. And then actually you're going to go about doing support. One tip which is worth considering is maybe in the beginning you may have some technology that scales fine, but you should think more about scaling up, right? How do you get a multiplicative advantage for what you're doing? So For example, if you have an email address people can contact you and you answer those emails, great. Every time you answer one of those emails, you've helped nobody else, right? And so figuring out a way to try to scale that up, maybe have a list, a mailing list, or a forum to try and get the fact that those answers can see better people, or better yet, have your community also contribute answers, right? So figure out a way to kind of scale up. So as a way to kind of talk about this, back working on the RISC-V project, this is with my colleague Chris. So the backstory, of course, our colleagues in the group, Andrew, Yunsep, and the advisors created RISC-V, and the goal is for teaching and research. And by 2014, a lot of us in the group had kind of been pulled into the project, and we were just getting swamped with emails about support. Like, how do we help this? GitHub issues. We didn't know what to do. And so we thought, what? This issue we just talked about, right? How do we think about scaling up and getting more benefit for support efforts? And so we decided we want to make a Stack Overflow. And it turns out you need 1,500 points to do so. It gets a little bit small on the screen. It's actually an email, I wrote from back then. And I was asking just, hey, grad students, does anybody have enough points to do it for us? And then shout out to Murdad, who did. What's funny about this is actually there's a legitimate concern if you read this that we might get a Stack Overflow tag revoked for not having enough questions, right? So there wasn't enough activity on RISC-V. This was a serious concern for us at the time. But luckily we got the tag made, and then Chris advertised, oh yeah, we have a tag, please use your tag, right? And so we made this tag, and so Chris and I answered a bunch of Stack Overflow questions for the remainders of our PhDs. We were number 1, number 2 on that tag for a long time, and then we stopped up answering those questions when we finished our PhDs, and now years later somehow we're still number 2, number 5. But I'm telling this story to kind of point out this is a way to kind of build inertia, build stuff, and what's nice about Stack Overflow in this case, for example, people only do web searches, go there, right? And so this is a way you've put some effort into support. Now other folks can see it and you can gain from that, right? So that's cool. And yeah, so between this efforts as well as we had a large group, a lot of people were helping in different ways, different types of support, different types of engagements. Around the same time, the group kind of pivoted, right? Where originally we were really excited about, just making RISC-V say for teaching and research, and then the leadership decided, you know what? Actually, the key feature is the free and open, right? And that's only became apparent when talking to people and interacting with folks. And should also, of course, acknowledge that RISC-V wasn't the only open and free ISA, not the first. Shout out to OpenRISC and of course this wonderful ORConf organization. Cool. Okay. Automation, also obviously a good thing. But what are some nuances about this in projects, right? So, obviously you can have makefile, scripts, build systems, et cetera, for your project. The good thing, of course, about automation, the more you do automated, it's not only easy for users to have to do less commands themselves. It's also less for them to get wrong. So you automate well, you make your support job easier, right? So this is one of those, additional benefits. But now, perhaps the underappreciated benefit is really thinking about what kind of community you're supporting, right? If you're helping those users who have a focused project and they want a certain functionality from your project, well, if the automation gets them to a working artifact quickly, great. That makes them happy, right? They don't need to read a bunch of documentation and learn a bunch of stuff. If they I need an HTML IP for system Verilog, and you have the automation to give them what they want, great. They're done, right? And then they're moving on. That's what they want. And so one tip I might add to this is when you're doing automation, perhaps consider not just having whole automation flow, but also saving intermediate results, including that too. So for example, if you have a long set of tools you're going to run, include some intermediate results. And the reason why this helps is because if the automation breaks for somebody, this can help them get underailed. So an example of automation, one of the projects I worked on as a grad student was bringing all the RISC-V tools to Homebrew, which is the macOS package manager. And the whole point of Homebrew is to automate stuff, right? You just want a package on your Mac. You don't care about learning and cloning and all stuff. You just want to do it. And so, hey, we automated it. It worked pretty well. Looking back in the 9 years of supporting this project, it's interesting how you can tell interacting with users, they really care about the automation, right? They're like, I ran this one command, I had this one error, right? Like they don't want to learn what's going on. Occasionally you run into users who do very exotic things to their Homebrew installations, and that causes problems for your automation, but they just want it to work, right? So these community interactions and support helped inform that idea of thinking really about helping people with those issues, right? And automation is important. Cool. Documentation, obviously another good thing, but talk about some nuances, right? So of course, if you have good docs, you can reduce your support load by answering those questions in advance. But some things I don't think people appreciate about documentation is sometimes they worry it needs to be really big and really long. It doesn't necessarily need to be exhaustive. Sometimes if you have the right combination of automation, the right project supporting the right users, you can actually be pretty concise but get to the point, right? Hey, here's how you clone my project and run the automation to get the result you want. Doesn't need to be super long. Doesn't need to be 100 pages, right? And then an interesting tip I might have is if you find it really hard to write documentation, it may not be a problem with documentation. It actually may be a problem with the way you've designed your project, right? If you start writing this like, OK, well, to understand my project, first you need to understand the foo object and the foo concept and the bar object, and you need to multiply the hierarchies and the baz object, and like, I just want to run this dude. Like, and so this is a sign you should think about. Maybe I have too much complexity and should refactor it out and rearrange your design. So it might be kind of a hint at like, oh wait, maybe if this is a 200-page doc for a 10,000-line repo, maybe I should rethink what I'm doing. OK, so as an example of this, with Sagar in the audience, we built an FPGA prototype for getting Rocket Ship on FPGA, right? So that was one of the first RISC-V cores, and so this is the easy way to get that on FPGA. And now talking about the three things we discussed, right? So support, yes, we were active in support. We answered GitHub issues. Interestingly, there was a very clear moment when the group decided to officially end support. And despite that, people online did not appreciate this and continued to ask for support because people liked the project. But yes, check for support. Automation, we worked really hard on this. So there are make files and tickle scripts. And so yeah, with this, you could basically just clone the repo and end up with a bit stream on the FPGA. Now, in light of what we talked about, we also had certain things saved. For example, if you had trouble getting the chisel flow going, this was pre-chisel 3 originally, we actually had the Verilog cached in case you wanted to just get the Verilog and see what's going on. Likewise, let's say you had a problem with the other end, getting Vivado to work, we also saved the bit files. So you know what? You don't even run this automation. You can just take the bit file and go. And so automation can really help your community understand what they wanted to do. We also had documentation. In this case, it was just a long README, but it was helpful. And actually, was both a blessing and a curse because it was a long README exposed in the internet, and so a lot of searches brought people there. A lot of people linked to it, and so this is part of why there's kind of continuing requests for support is folks are just seeing that content, like, oh, this is great, this is relevant. And so documentation actually can be real helpful. And so yeah, so what users are we helping? We were helping people to regain started RISC-V, right? And yeah, so understanding that, having things like support, automation, documentation, these are all really important to kind of help that community thrive. Now I'm going to kind of sneak in my graph research. People at the time when I was doing my PhD research were proposing all sorts of graph frameworks, high-performance graph frameworks, new algorithms. But there wasn't really much standardization. Everyone kind of wrote their own evaluation for every paper, and it was kind of crazy. So I made a benchmark to try and standardize things. And along the benchmark, I released reference code. OK, here's an example of following the rules for the benchmark. And oh, yeah, it's decently optimized. It should be nice. The experience of maintaining this project actually kind of showed me a lot about what communities you're supporting versus who actually ends up using your project, right? So I did support this, right? People would email me and answer a lot of questions, or I'd have GitHub issues. It was extremely automated. It's actually one of the reasons why this project was well adopted was because it was completely makefile based and zero dependencies. So one of these things was nice. So a lot of graph frameworks at the time required a bunch of dependencies. And we're saying, no. So plus 11 compiler, that's all you need in your rolling. People really appreciated that. And actually, it was actually very well documented. So it wasn't just some code and a README. It was actually a long archive paper talking about the benchmark as well as the science decisions we made with the kernels. And so when I made this for high-performance graph community, thinking people would use this to compare against their own graph frameworks. It's actually not who ended up using it. This is why it's important to kind of talk to your users and figure out who's actually using your code. And so, like I said, I was hoping to help the HPC graph community. The people who actually ended up using it were almost everyone else, right? So people in the architecture community who wanted the workload, they love the automation, right? So appreciating what your users are appreciating about. They love the fact that they were somebody who was an expert in computer architecture. They wanted to design their processor, and they wanted to think about processor stuff. And oh, wait, I can just clone this repo, type make, and I have a graph workload. Great. That's easy. So that's what they liked about it. So that was kind of the feature for them. Understanding kind of what made them happy, right? And so, yeah, a couple years ago, I realized, OK, that's what folks want. And so as I continued to steward and maintain this repository, I focused on keeping that important, right? Keeping the automation there, keeping it simple, having no dependencies, et cetera. So here's the RISC-V team back at 2014. So you can see already by then it was a pretty big team. And so 10 grad students, 2 professors. So you can imagine that here we are working many fronts, compilers, hardware, also support, documentation, automation. We can do it all. Well, that's great if you have a big team. Not every project has a big team, right? And so no, you don't always have 10 grad students. And so, for example, on the project I'm talking about next, this is me working on it as a postdoc. And you can probably guess when I took a faculty position. And you can also see maybe a summer in lockdown, I got some time to code again, right? But you can see it's tough, right? So, OK, so now you have much less time to develop stuff. How do you kind of prioritize, right? And so, as Jose mentioned in his last talk, number one, sometimes you got to prioritize the research mission over the community, right? Which isn't always great for open source, but as I said, we're trying to keep our jobs. But if you have limited resources, this is where it gets really important to help with prioritization, right? Where if you have a lot of people, sure, you can do everything. I can do full documentation, full support, full automation, everything, right? But if you have less of that, you really want to understand who's using your project, and then you can better tailor those efforts to be matched. Cool. So this essent project I mentioned, this is something I started, but my students have done great things. So the goal was to build the fastest RTL simulator. And so we originally did this serially, and that was great. And then just recently, Hao Yuan presented earlier this week. As a result, we parallelized it in this fantastic parallel results. That's the good. That's pretty awesome. What's the catch? Well, there's a few of them, right? So one, we have some long compile times. It's not fundamental to the tool, but we need to spend some engineering effort to fix that. And there's some other rough edges. So it's not quite ready to be a daily driver. And the ugly, well, if you go peek to the code, it's a gross monolithic software architecture, right? So it's not a nice compiler of passes. It's this big thing, right? And so, yeah, you can also tell I apparently like the good, the bad, the ugly, like Jose. But that's the current status of things. So how about my users? Who are the users of this tool? Honestly, I don't know, right? I know a couple of them, but I'm not sure how many there are, and I don't fully understand them. And that's kind of a problem. So you're saying, OK, well, based on the last talk so far, how's support, automation, documentation going? Well, they're all so-so. And guess what? If they're all so-so, this is the kind of usage you get, right? This is what, get what you deserve, right? And so this situation we're in, now, there is a way out of this, right? We've been making some really good contributions. We've actually had some great work by the students in just the last few months. For example, we finally got VC support as of like 2 weeks ago, which is great. It's obviously a nice feature to have. It's something you shouldn't just put off for 6 years. But we're working on it, right? And so what's the future for us? Yeah, we're working on specific collaborations. And with these specific collaborations, it allows us to kind of be more focused about what are we working on technically as well as supporting. All that being said, as an academic, there's also Plan B, which is TUI, which is bad industry jargon speech for transfer information. In other words, even if this artifact is not what's adopted by the community, getting your ideas out there and into other tools is also successful, right? So that's Plan B. Great. I'm also going to toss in a slide on part of why I'm so busy, not able to do so much time for Essence. I'm working on a Agile hardware design course. I've taught this 3 times now at Santa Cruz, and so it's actually completely open sourced. And so all the lectures, assignments are all there. So this course is taught with Chisel. And so perhaps you might like the more gradual way to learn Chisel over time. And yeah, the lectures are in Jupyter, so you can play with the code. You can go ahead and run with that. You can see videos of me on YouTube. And so with this project, we were, of course, extremely focused on students in the course. That's why we're doing this. And keep adjusting the course based on their feedback and et cetera. But what's been interesting is that we've got people outside our community, or outside our campus who are using this course sometimes. And we want to learn more about them. And one of the challenges actually is currently structurally, we actually have a great way to interact with them, right? So for example, occasionally we get these very nice YouTube comments, but it's like, OK, how do I know more about what you're doing? How do I help you? And so yeah, I need to figure out a mechanism for next offering, so some way they can kind of participate and get involved and figure out what's going on. So we'll figure out how to do that. Cool. OK, so wrapping up my talk, hopefully motivated you why you should think about your community and how to best support your project. I'm going to throw 2 other pieces of wisdom out there for this video John's putting together. One is I think it's really important for a project to get some sort of proof of concept working quickly, within 4 or 5 weeks at most, maybe a week or 2, right? It takes you a year or 2 to get your first result. That's too long, right? Because there's a difference between proof of concept and like actually the real tool and supporting it and releasing it. And so if you take a year to get there, it's a lot of sunk time. You're going to probably be more susceptible to sunk cost fallacy, and then it may not work out, right? And so you want to get that first result. Doesn't mean it's publishable. It just means, OK, the key idea is able to code it up and see the key aspect at work. That's kind of important. And so part of where this idea came from is actually one of my colleagues in grad school literally wrote Spark in 4 weeks. This is Matei Zaria, and he's the one people who goes around shouting this wisdom, right? Because he believes, yeah, if it takes more in this, there's so much other time after the first proof of concept that it's just too much of a multiplicative factor. The second bit of advice is that open source is software, and you should think a lot about your software architecture. And so I'm going to plug a book I did not write. This is by John Osterhout of Philosophy of Software Design. It's actually a really good book. It's really short. It's really cheap. And if that's not enough, the first version's open source on the web page. Now you may be wondering why I'm promoting a book by somebody whose web page is on PHP. Don't worry. If his name is not a household name, John Osterhout, it should be, because this is the person why we have Tickle and the EDA tools, right? So this individual not only created Tickle, but also was one of the EDA pioneers, and that's how this happened. So this person is an extremely influential programmer in our community, and this book is really good advice. And of course, I should also repeat what I said earlier in this talk. Think about your users. If you build it, who will come, and then how can you support them with support, automation, documentation, etc. And with that, I'm happy to take any questions.
I think it was a great talk, and a lot of it was a good checklist also. I will definitely use that. Just thinking, so far, the best way to find users of open source projects for me has to be by introducing bugs. Then you suddenly know all users. Do you have a better idea how to accomplish that?
Yeah, when users fix bugs, that's amazing, right? Like for the graph work, in that graph code base, that was really funny where there's one algorithm there where I took an established algorithm, coded up my own version of it, put it in there, and this person sent me a bug fix for it, and actually they found a bug in the algorithm around for 30 years that nobody knew about. So that was actually really cool. And then they went off and published a paper, and that was awesome for them. So yeah, those intentional bugs are a great way to find users. But no, I'm happy to hear it. I'd love to hear more from the community, right? So as mentioned earlier by someone else, right, you have your GitHub stats. You can look at that and keep an idea of what's going on, but it doesn't really tell you a whole lot about how they're using it, right? For academics, if you have papers and you're willing to wait some time, you can see what papers cite you, and that gives you some idea of what's going on. But yeah, I think learning who users are is really important. I think it's a good discussion for the community. I don't have any more tips. I kind of gave you what I know, but happy to learn more.
I wanted to give you a chance to give a more positive pitch for Essent to the room. Could you tell us all why we should adopt Essent rather than worrying about the monolithic code base?
Sure. I mean, so we use this opportunity to kind of pioneer some techniques for really fast simulation. And so yeah, it's kind of a fun way to go about doing that. By building on top of the Scala FOSSi, we actually have an extreme productivity advantage, right? So part of why we'll do the things we're able to do is because in a few thousand lines of Scala, we're doing more sophisticated algorithms than 100,000 lines of C++ for Verilator, right? That's kind of the advantage, is that productivity advantage allows to us, we have only finite developer resources, we can kind of do some really cool concepts and some really cool graph tricks. Yeah, so that's kind of why it's cool. Yeah, you're right, maybe we should give more positive light.
They can get super linear speed up in parallelization for the number of cores that you have in your machine. So you should definitely check it
for
out.
large design, yeah. So we have how you want to resolve 27x speed up on 24 cores. So yeah, so we can definitely go fast.
All right, right out here.
A question about the benchmarks. Are you considering the graph neural networks these days?
Oh, good question. So for the graph benchmark, am I doing graph neural nets? No, but that's a good suggestion. So this benchmark speed was originally created in 2015, 2016. So it's kind of like almost a time capsule now of just static graph kernels, right? So at the time, your classic things like breadth first search, connected components. And at the time, we were just trying to learn how to do those. But you're right. And in the years since then, the graph community's kind of moved on to other things, right? There's now dynamic graphs. Graphs where data is changing as time is going on. There is people are really obsessed with pattern matching. It's a really important problem that's emerged in the last few years. Also, as mentioned, GNNs, graph neural networks, graph convolutional networks, et cetera. Yeah, so notice benchmarks there, but perhaps maybe a version 2.0 can consider this. Sure.
How about sparse data?
It's all sparse.
It's all sparse.
Yeah. So I guess one other theme of my research is I've done a lot of work optimizing sparse applications. That's a common theme through my work.
Cool. Okay. Well,
Great.
thank you very
Thank
much,
you.
Scott. Another round of applause.